Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Khairulnaim bin Mohamad Salleh, final year student of School of Engineering UiTM Shah. I'm going to present my final year project proposal, which title of the project is Unmanned Vacuum Hose Assembly System. Throughout the entire project, I have been supervised by IR Dr. Noor Azlina binti Mohamad Salleh. In this presentation, I will cover all of these contents one by one. Summary: the project is focused on the development of vacuum hose assembly process in order to produce a complete functional vacuum hose. The machine will include the automatic machine criteria in which it contains the motors, sensors, controllers, and suitable technologies. By utilizing design and lean methodologies in this research, the project will develop new conceptual design, and at the end of the project, an unmanned assembly machine will be introduced to the company. Project is a collaboration effort between Paracel Sedam Hyde. The main product of the company is vacuum hose. The production of the vacuum hose consists of two manufacturing lines, which is extrusion and assembly line, and this project only focuses on assembly line. The company urged to upgrade the assembly machine to compliance with the IR 4.0 project. Also, this project supports the Sustainable Development Goal number 8 and number 9. Next, we move to the literature review. Some research and readings have been done regarding to the project. First is the previous research on automated assembly machine. According to Viga and Causi, in order to have a successful assembly mechanism, they highlight the use of gripper and clamp, which is powered by pneumatics or motors. The gripper's finger must hold the components neatly by having positive, agile, and self-centered grasp. Also, the papers portray the use of modular track and conveyors in channeling the product between the work cells. In other research, Urapan has shown that the use of auto feeders is efficient and convenient method to feed components effectively into the manufacturing process. It says that this approach is cheaper than gantry systems and robots. Throughout the paper, the behavior of the feeder is studied and discussed. Next, a research is reviewed and studied about the cutting process. Mentaker explained in his research about the effect of the cutting plays big role in assembly process. Furthermore, the cutting angle and the blade sharpness are important factors in making a good cutting. Also, based on Kurt's research, it requires suitable techniques and parameters in cutting specific type material such as plastic or rubber. Lastly, the automation control for machine is well discussed by Solomon and Zhao in their respective papers. They say that Arduino and PLC are proven working in controlling the machine system. These microcontrollers need to complement with sensors and actuators, along with well-defined instructions to work properly. For best monitoring and controlling approach, it is recommended to adapt the IoT, which is Internet of Things, to the system. Now, we proceed to the problem statement of this project. First, the assembly process is manually hand-operated by the workers. This creates unstandardized workflow and inconsistent output of the product. Besides, the quality of the production is affected by the operator's performance, hence it is difficult to control the production. It has three objectives that needs to be achieved. The first one, to identify the parameters of vacuum hose assembly process by accessing various data and sources. Two, to design potential conceptual ideas and fabricate the unmanned assembly machine of vacuum hose. And the last one, to apply suitable technologies that complement automated assembly system. We move to the scope of the project. The project scope is a development of an unmanned vacuum hose assembly machine by designing and analyzing the conceptual ideas and fabricating the machine. There are several limitations found in carrying out the project, which are the machine needs to precise, thus requires a lot of data. Next, the subparts condition and state, as the hose is flexible and the connector rings need to control its orientation. And lastly, the allocation time to complete the fabrication of machine is too short. The methodology used in this research is by combining the design methodology and lean methodology. Lean methodology is as shown on the left side. This method is aligned with the design methodology, which is DMADV method. First step of the methodology is data collection. Data is collected directly by visiting the site, which is the assembly line of the company. Many aspects are observed in terms of space area, workflow, efficiency, and workers' behavior. Moreover, Procedures of the assembly process is also observed as the main reference to the study of the process. Second step of methodology is current work standardization analysis. In this method, the assembly process is analyzed and identification and division is concluded. The assembly process is categorized into several processes, which are host alignment, host trimming, gluing process, connector orientation fixing, assembly process, channeling process, and storage sorting. From the previous analysis, the research is carried on by using future Kaizen works standardization. Several possible designs are determined according to the preference and suitability of each mechanism. In the table shown, there are three types of options of design to fit all the requirements of assembly process. The selection of the element mechanism is based on the previous research and studies. Next, based on the generated ideas of the options design, the possible design is analyzed by using path chart. In this analysis, the criteria to be evaluated are feasibility, practicality, ease of maintenance, efficiency, space usage, simplicity, and aesthetics. The weightage is determined according to the level of critical of the criteria to the machine. From here, it can be observed that the total scores for option 1 is 4, option 2 is 8, and option 3 is 14. The best design is option 3, design as it has the highest total score compared to the others. Furthermore, this machine needs to be equipped with suitable technologies in order to operate automatically. The system configuration to achieve automated machine is as shown in the system block diagram. The sensor detects input and sends the signal to the microcontroller to act accordingly. Feedback is sent back to the input for continuous process flow. Also, the machine can implement the Internet of Things to monitor the performance of the machine and the process. The flow process of the IoT is shown as the block diagram for IoT implementation below. Last methodology approach is improved work standardization analysis. The system and operation performance can be monitored to achieve high quality output. These performance levels can be obtained by using overall equipment effectiveness, or we call it OEE indicator. The data is extracted from machine to cloud through IoT solution. This method is able to monitor the process performance, output defects, and the assembly line behavior as a whole. Hence, continuous improvement can be done. From the research and study of the project, some preliminary results are determined. The first one is time measurement check sheet. In this check sheet, the current assembly process is identified into specific tasks. The time for every task is recorded for 10 times, in which 5 times in the morning and 5 times in the evening. To ensure the data gathered is not biased by the performance difference at the beginning and the ending of the working time. By using these tools, the task is classified into level of essential. By adapting the Kaizen concept, thus a more efficient solution can be issued. Second preliminary result, the conceptual designs from the several options stated before are visualized. This is the conceptual design for option 1. The design uses Karakuri concept for the host to traveling from one zone to another. For second design, it also uses Karakuri concept as it utilizes the gravity force. The idea to have a zigzag channeling path makes it less space usage. Even though the design seems futuristic and convenient as it combines the gluing and assembly process at gripper, the feasibility of the mechanism is difficult to achieve. And for the last design, the assembly process is split into 4 zones according to the specific process. The usage of conveyor system with jigs may use a lot of spaces, but is more feasible and practical. It is easier to control and monitor the assembly line. Also, the maintenance works can be done easily because every process is operated independently. Last but not least, the expected result for this project is to eliminate the current manual process. This can be achieved by detailing the parameters and product description specification, which is PDS, of conceptual design of option 3. The fabrication of unmanned vacuum hose assembly machine will be done in next semester for FYP2. It is expected that by the completeness of the machine in next semester, Internet of Things will be implemented to fulfill the real-time monitoring of the assembly line. That's all for my final year project proposal presentation. If you have any inquiries, you can reach me through this email address or contact number. Thank you very much for your time and attention.